Okay, so let's unpack this. If you're a computer science graduate, standing right at the beginning of your career today, the tech world, it's just buzzing with opportunity. It's huge.
Absolutely huge.
But let's be real, it can also feel a bit overwhelming, right?
Oh, for sure.
How do you even start? How do you find your specific niche with all this stuff going on? It's definitely not just one single road anymore. It's more like this sprawling network of paths, all interconnected, always changing.
Yeah, constantly evolving.
So this deep dive, think of it as your strategic map. We want to help you navigate this whole dynamic tech sector, for 2025 and beyond, especially if you're aiming to build that really deep, impactful expertise right from the start.
Right.
We've pulled our insights from this really comprehensive guide. It's packed with the big macro trends, the core specializations, and even a kind of strategic playbook for landing that crucial first job.
Yeah, the practical steps.
Exactly. So our mission here, it's to pull out the most important nuggets of knowledge to help you, our listener, make really informed, deliberate choices about your own career path in tech.
And what's really fascinating here, I think, is how these big trends, they aren't separate things. They actually interweave, and they're fundamentally reshaping what it even means to be a successful tech professional in 2025.
Okay.
So the first one is what we're calling the AI substrate, basically AI and machine learning. They're not siloed disciplines anymore. They're becoming this foundational layer that's just everywhere. You see it in coding tools, you see it in cybersecurity.
So AI is kind of baked into everything now.
Pretty much. We're talking AI-assisted coding tools that fundamentally change how developers even work. Or, these sophisticated machine learning models powering cybersecurity threat detection. So having a baseline understanding of AI principles, it's rapidly becoming an expectation for all tech pros, not just the AI specialists.
Right, so it's less about becoming like an AI guru yourself, maybe?
Yeah.
And more about just understanding how AI is woven into the fabric of everything. Like, you got to know the basics of electricity, even if you're not an electrician.
That's a great analogy. Exactly.
That makes total sense. And it connects immediately, I guess, to the second big trend you mentioned, the rise of the hybrid professional.
It does.
Because those old, really rigid lines between roles of, you're just a developer or just ops or only security, those seem to be dissolving.
They really are. The most valuable professionals today, they're often described as T-shaped.
T-shaped, okay.
Yeah, so they've got that deep, maybe world-class expertise in one main area that's the vertical part of the T. But crucially, they also have a broad functional understanding of fields right next to theirs that's the horizontal top of the T.
Ah, got it. Like, give me an example.
Sure. Think of maybe a back-end developer who also really gets cloud infrastructure, or a cybersecurity analyst who can actually write Python scripts to automate tasks, or even a front-end developer who's got a really good eye for UX design and can talk that language fluently. These hybrid folks, they consistently outperform people who stay just in their silo.
Yeah, I can see that. And the third trend you mentioned, this one feels really key for new grads. The portfolio is the ultimate proof.
Yes, absolutely critical. Look, your computer science degree, it gets you to the table. It opens the door.
Right.
But in 2025, honestly, with online learning, boot camps, that degree alone doesn't signal unique aptitude like it maybe once did. The real insight here is that your portfolio, it's not just a list of projects, it's tangible proof. It shows your grit, your initiative to actually build things, your ability to ship something.
Stuff you can't really teach in a classroom.
Exactly. Recruiters are actively looking for those qualities, and you just can't fake it.
It's really interesting how these three things weave together then. Like, AI is everywhere, so you need that baseline knowledge.
Right.
But if everyone has that, how do you stand out? Well, you become that T-shaped person with broader skills. And the only way to prove you have both that AI foundation and those T-shaped skills?
Your portfolio.
Your portfolio. Yeah, you see how they connect. It's neat.
It really shapes the landscape.
Okay, so with those big trends, the AI substrate, the hybrid pro, the portfolio proof, how do you actually apply this? Let's zoom in a bit. Let's talk about the specific areas where you can build that deep expertise, starting with, well, what many people think of as the bedrock, the builders.
Right, the builders. This is really software engineering and development. It's still the engine room of tech, right? Often the most direct path for CS grads. But there's an important shift in, like, the titles you should be aware of. The simple computer programmer title. That's actually projected to decline.
Oh, interesting.
Yeah, the market really values software developer, implying focus on the whole application lifecycle and software engineer. which suggests a more rigorous engineering principles approach to complex systems. So for you listening, aiming for roles with developer or engineer is probably key. It emphasizes problem solving, system architecture, not just cranking out code.
Gotcha. So within this huge builders category, let's start with front-end development. This is what the user actually sees and interacts with, right?
Exactly. They're the architects of everything. Visual, the buttons, the menus, how things feel responsive. Junior roles often start smaller, like building a specific component, maybe a navigation bar or login form.
So for 2025, what are the absolute must-have skills if you want to go into front-end?
Okay, core web languages, HTML, CSS, modern JavaScript, that's your absolute foundation. Non-negotiable.
Right.
But the real game changer now is mastering at least one major component-based framework. React is dominant, but knowing one deeply is key.
Why is that so important?
It's how you build complex, interactive UIs efficiently. It keeps your code modular, manageable, it's just how modern front-end is done.
Okay. What else?
Beyond that, responsive design, making things look good everywhere, phones, desktops, utility-first CSS like Tailwind or Sass for faster styling, Git, obviously, for version control, and build tools like Webpack or Vite to bundle your code, make it performant, and finally, testing frameworks, Jest, Cypress, to make sure your stuff actually works and doesn't break. That's crucial for professional work.
That's a pretty solid list for front-end. But I'm curious, how competitive is it really for new grads? Is the demand huge, or is it like a really tough nut to crack right now?
It's both, actually. The demand is high, definitely. But that means it's also highly competitive. And frankly, it's pretty saturated at the entry level.
So how do you stand out?
You need skills that go beyond just the basics. Think performance optimization stuff like lazy loading, understanding core web vitals, web security basics like preventing XSS attacks, and really demonstrating you can write robust, testable code that integrates well. And that polished portfolio with live, working projects, it's not a nice to have anymore, it's essential.
Got it. And salary-wise, entry level.
In the U.S., you're typically looking at somewhere between, say, $65,000 and $82,000 to start.
Okay. So if front end is like the shiny dashboard and comfy seats of a car,
Yeah.
then back-end development must be the powerful engine hidden under the hood.
That's a good way to put it. Back-end devs build the server-side logic. The database is holding all the info, the APIs that let different parts talk to each other. It's invisible to the user, but it's fundamental. Yeah. Functionality, performance, scalability, it all relies on the back-end.
And junior roles there, what do they typically do?
Writing and testing core code for specific features, designing database schemas, optimizing how you query data, and of course, squashing bugs.
So what's powering these back-end engines these days? What tech do you need?
Deep proficiency in at least one major language and its main framework is vital. Think Python with Django, or Flask, maybe Java with Spring Boot, or Node.js with Express. Those are big ones.
Right.
You also need a solid grasp of databases, both relational, like PostgreSQL or MySQL, and non-relational, like MongoDB or Redis. And not just using them, but designing them well, optimizing queries.
Okay.
API design is core RESTful or GraphQL. Increasingly, you need some understanding of system architecture, things like microservices, load balancing, and even some cloud and DevOps fundamentals are expected now. Basics of AWS, Docker, Kubernetes,
Wow, that's quite a bit.
and security. Can't forget security fundamentals, authentication, encryption, preventing things like SQL injection. It's a lot, but it's crucial.
So what's the job market like for a new grad wanting to start in back-end?
Demand is exceptionally strong,
Yeah.
and it's generally less saturated than front end, but the barrier to entry is higher.
Why is that?
Companies expect a deeper grasp of those core computer science principles. They need critical thinkers who can build for scale, reliability, security right from the get-go. So your portfolio needs to show more than just code. It needs well-designed systems, clean APIs, solid data models, maybe even some cloud deployment.
Makes sense. Okay, then there's mobile development, apps for, the billions of phones and tablets we all carry.
Yep. Divided mainly into iOS for Apple stuff and Android for Google. Some devs specialize, others use cross-platform tools to hit both.
And junior roles.
Implementing features, working closely with UI/UX designers, bug fixing, optimizing performance so the app feels snappy. Pretty standard development tasks, but focused on the mobile context. For iOS, you're looking at Swift, namely that's the modern language. Xcode is the environment, UI frameworks like Swift UI or the older UI kit, and you really need to understand Apple's human interface guidelines.
Okay, and Android.
Kotlin is the official language now, recommended over Java. Android Studio is the IDE, the Android SDK, of course. Jetpack Compose for modern UI and other Jetpack libraries like Room for databases or Retrofit for networking. And understanding Google's material design is key.
What about hitting both at once?
Cross-platform tools like React Native or Flutter are super popular and very versatile for that. Let you write once, deploy mostly everywhere.
The junior job market for mobile sounds like it's absolutely
It
booming.
really is. Explosive growth projected like 26% between 2022 and 2032. It's huge.
Wow.
But that growth also means fierce competition, and the single most important factor for junior mobile devs.
Let me guess. Portfolio.
Bingo. But specifically, a portfolio of polished, functional, and ideally published apps on the actual app stores.
Actually getting it out there.
Yes, that's concrete proof you can take an idea from concept all the way to a real product people can download. It's massive.
So, okay, whether you're building the visible UI, the hidden engine, or the apps in our pockets, it's clear it's not just about the code itself, is it?
No, not at all.
It's about really understanding the whole ecosystem you're building for.
Exactly. The context matters hugely.
All right, so if the builders lay the foundation, who keeps it all safe? This next pillar feels more critical than ever. The Guardian's cybersecurity.
Absolutely mission critical. I mean, look at the value of data today. And the field has this persistent major talent shortage.
Right.
Historically, it was often a role you moved into after years in IT or networking. But now you're seeing more direct paths through specialized degrees and certifications. But regardless of how you get there, it fundamentally requires what people call a hacker mindset, that curiosity, that way of thinking, and real practical hands-on skills.
And it kind of splits into two main camps, right? Defensive and offensive.
Broadly speaking, yes. Defensive is often called the blue team. Their main job is protecting systems, networks, data. They're the shield.
Okay.
Entry-level roles are often junior cybersecurity analysts. They're monitoring for breaches, investigating alerts, helping out when there's an incident, often working in a security operations center, a SOC.
So what tools and knowledge do they need on the blue team?
Deep understanding of networking, TCP/IP, DNS, the works. Operating systems, Linux, Windows. Hands-on experience with security tools is key. SIEMs like Splunk or Logarithm.
SIEMs?
Security information and event management. Basically, systems that collect and analyze security logs from everywhere. Also, IDS-IPS, intrusion detection prevention systems, vulnerability scanners like Nessus, and crucially, knowledge of threats, phishing, malware frameworks like the MITRE ATD and CK framework help organize that knowledge. Plus, some basic scripting, maybe Python or PHP for automation is a big help.
And the job market for junior defenders.
Demand is at an all-time high, but entry can be tricky because companies are understandably risk-averse.
Yeah, you don't want the rookie guarding the crown jewels on day one.
Exactly. So certifications like CompTIA Security Plus often act as a mandatory filter. And internships, incredibly valuable for getting that practical experience employers want to see.
Okay, then there's the other side. Red team, offensive security, sounds a bit more proactive.
It is. Think of them as ethical hackers. Their mission is proactive security. They simulate attacks, try to find and exploit vulnerabilities before the bad guys do.
So they're like testing the defenses.
Precisely. They find the holes, then report back with recommendations on how to fix them. Penetration testing is a big part of it.
What does it take to be on the red team? That hacker mindset.
That's paramount. That curiosity, creative problem solving, persistence. You also need advanced understanding of networking, web, and mobile app security, even lower-level stuff like memory management. And proficiency with offensive tools is non-negotiable. Metasploit, Burp Suite, Nmap are classics.
What about certs for red team?
CEH Certified Ethical Hacker is often seen as an entry point. But the OSCP Offensive Security Certified Professional, that's the industry gold standard. It's a tough, hands-on exam that really proves you can do it.
But getting into red teaming as a new grad sounds tough.
It is. Direct entry-level roles are significantly rare. Most people transition after years in related fields, blue team, sysadmin, software dev.
So what does a new grad need?
An exceptional portfolio. We're talking documented bug bounty finds, high rankings in Capture the Flag, CTF competitions, contributions to open source security tools, or maybe even having that OSCP already. You need to really stand out, which raises a really important question for new grads. The demand for cybersecurity is huge, yes. But how do you bridge that gap? How do you get that proven experience companies want, especially for offensive roles that feel so exclusive?
Yeah, that's a great challenge. It sounds like a field where you really have to just live and breathe it almost. Prove yourself through action.
Definitely.
Okay, so we've got Builders creating things, guardians protecting them. But who makes sure everything actually runs smoothly, scales up, doesn't crash? That brings us to the enablers: DevOps, site reliability, and cloud engineering.
Exactly, and these roles are deeply intertwined. They're really converging in many ways. Well, DevOps is more the culture, the philosophy, breaking down silos, automating everything. SRE, site reliability engineering, is kind of the engineering discipline for reliability, applying software principles to ops. And cloud engineering is applying all that specifically on public clouds like AWS, Azure, GCP.
So the focus should be.
Understanding how to use DevOps principles to build reliable, scalable systems, primarily in the cloud. That's where things are heading.
Let's start with DevOps engineering then. What's their main goal?
Accelerating and streamlining the whole software development lifecycle. They do this through automation, building internal tools, and fostering collaboration between dev and ops teams.
And junior roles.
Installing and configuring automation tools. Monitoring CI/CD pipelines, that's continuous integration, continuous delivery. Writing infrastructure as code scripts, helping with software releases.
Okay, key skills for DevOps.
Strong practical knowledge of at least one major public cloud. AWS is the market leader, so that's a good bet. Infrastructure as code, or IAC, with Terraform is huge.
Terraform, yeah, hear that a lot.
CI/CD pipeline tools. Jenkins, GitLab CI, GitHub Actions. Containerization with Docker is fundamental, and orchestration with Kubernetes is becoming almost as vital.
Docker and Kubernetes, got it.
Plus configuration management tools like Ansible, Puppet, or Chef, and scripting Python, Bash, maybe Go.
DevOps sounds like it's in massive demand. Can new grads get in directly?
Demand is incredibly high, yes, but direct from university roles are still a bit rare. Usually companies want some foundation, either in software development or maybe system administration.
So CS grads are well placed but need practical skills.
Exactly. Your degree gives you the theory, but you need the hands-on. Your portfolio should show a full CI/CD pipeline you built, some Terraform code, maybe an app deployed with Docker and Kubernetes.
Any certs help here?
Foundational cloud certs like the AWS Certified Cloud Practitioner definitely boost your profile, shows you've got the basics down.
Okay, then there's site reliability engineering, SRE. You said that's like applying software engineering to operations. Sounds intense.
It is. SRE's core mission is achieving ultra-scalable, highly automated, exceptionally reliable systems. They are the absolute guardians of uptime and performance.
How do they do that?
By automating repetitive tasks, what they call toil, setting really clear service-level objectives, or SLOs, managing error budgets, capacity planning, participating in on-call rotations, and fostering a culture of blameless postmortems when things do go wrong.
So they need all the DevOps skills.
Plus deeper software engineering chops. They're often building operational solutions using Go or Python. And critically, they need a deep understanding of distributed systems theory.
Distributed systems, like how Google search works across thousands of machines.
Exactly that kind of thing. CIP theorem, consistency models, how to make many computers work together reliably even when parts fail. And they're experts in monitoring tools like Prometheus, Grafana, Jaeger. They live by data SLIs, SLOs, error budgets.
Wow, so junior SRE roles, I'm guessing, are not common?
Extremely rare, especially right out of university. You mostly find SRE roles at very large tech companies, think Google, Netflix, places like that.
So how do people become SREs?
Usually after several years as a back-end engineer or maybe a senior DevOps engineer. For new grads, you'd likely need an exceptional academic background from a top school in algorithms, OS, distributed systems. And even then, you'd probably get hired into a general software engineering role first and transition later.
Right, definitely not an entry-level walk-in. It sounds almost like the special forces of ops.
Kind of, yeah. Highly specialized, highly skilled.
Okay, so DevOps helps streamline, SRE ensures reliability. But where do these operations actually happen most often now? That leads us straight to cloud engineering.
Exactly. Cloud engineering is all about designing, deploying, managing, maintaining applications and infrastructure, specifically on those big public cloud platforms, AWS, Azure, GCP.
They're leveraging all the services those vendors offer.
Precisely. The whole ecosystem, compute, storage, networking, databases, AI services, everything the cloud provider offers. Junior roles typically involve helping provision resources, configuring networking and security, monitoring cost and system health, troubleshooting cloud issues.
Skills needed for cloud engineering.
Deep hands-on knowledge of the core services of at least one major cloud provider is essential. Strong networking fundamentals, VPCs, subnets, firewalls, DNS in the cloud context, scripting, Python or Bash usually, infrastructure as code, Again, Terraform or the cloud provider's own tool like CloudFormation for AWS. And understanding cloud security best practices, like IAM for permissions.
And the job market for cloud engineering.
Massive growth, something like 18% annually projected. That fuels enormous demand. It's actually one of the most accessible infrastructure-focused roles for new grads.
Oh, really? That's good to know.
Yeah, mini start is maybe a cloud support engineer or similar. The most effective way to get competitive here, get certified. A foundational one, like AWS Certified Cloud Practitioner, is good. Even better is an associate level one, like the AWS Certified Solutions Architect Associate.
Yeah.
That really shows you understand how to build on the platform.
Okay, so summing up this enablers pillar, if you love systems, making things run smoothly, automation, this is your sweet spot.
Definitely.
But you've got to be ready to get seriously hands-on with the tools, especially things like Docker, Kubernetes, Terraform, and the cloud platforms themselves. It's like solving a complex puzzle every day.
It really is. Very rewarding if you enjoy that.
All right, let's switch gears now. From the infrastructure to the insights, let's talk about the strategists, data science, AI, and machine learning.
Ah, yes. This is consistently one of the hottest areas.
Mm-hmm.
High-paying, intellectually stimulating, really exciting stuff happening here.
Yeah.
But the broad title data scientist, which used to cover almost everything, it's fragmenting. You're seeing more specialization.
Into what?
Primarily into data analyst, data scientist, more focused on modeling now, and machine learning engineer, or ML engineer. And for CS grads, that ML engineer path often feels like the most natural fit because it leverages those core software engineering skills so heavily.
Okay, let's break those down. Start with data analytics. What's their main job?
They're the bridge between raw data and business decisions. They collect data, clean it up, which is often a huge part of the job, analyze it, interpret it, all to help the organization understand performance and make better choices.
So they're like data storytellers.
Exactly. Identifying trends, creating visualizations, building dashboards, communicating insights to stakeholders who might not be technical at all. That communication piece is key.
What skills do data analysts need most?
Expert-level SQL. Honestly, that's probably the most critical skill.
SQL first.
Then data visualization tools. Tableau, Power BI, Looker are popular. Programming for data analysis, usually Python with the Pandas library or maybe R, and crucially, strong business acumen. You need to understand the business problems, ask the right questions, and explain things clearly.
Job market for junior analysts.
It's one of the most in-demand entry-level tech jobs globally. Lots of companies have pretty established hiring pipelines for junior analysts.
So how do you stand out?
A strong portfolio, again, show the full workflow, getting data, cleaning it, analyzing it with SQL and Python, and building a really compelling, maybe interactive dashboard. That's proof.
Okay, moving up the chain maybe to data science proper.
Yeah.
How is that different from analytics?
Data science goes beyond just analyzing the past. It's more about predictive and prescriptive analysis, applying scientific methods, algorithms, statistics to extract deeper knowledge.
So building models.
Yes, building statistical and machine learning models to predict future outcomes, understand complex behaviors. They often own the whole modeling life cycle, from forming a hypothesis, getting the data, training the model, validating it, and communicating the results.
What are the key skills for a data scientist?
Mastery of Python is pretty standard, especially libraries like Pandas, NumPy, and scikit-learn for machine learning. R is also valuable in some circles, but the real differentiator, a very strong foundation in advanced math and statistics. Linear algebra, calculus, probability theory, statistical modeling, hypothesis testing. It's non-negotiable.
Right, the heavy math.
Deep understanding of ML algorithms, both theory and practice. And familiarity with big data tech like Apache Spark is often needed too.
What about getting a job as a junior data scientist?
Highly competitive, significant barrier to entry. A lot of roles actually require a master's or even a PhD.
Ooh, so for bachelor's grads.
You need to be exceptional. A stellar portfolio showing end-to-end ML projects. Deep, demonstrable understanding of the math and stats. Ideally, top internships or maybe strong performance in competitions like Kaggle. It's a high bar.
Okay, and then the third one, which you said might be a great fit for CS grads, machine learning and AI engineering.
Exactly. Think of ML engineers as software engineers who specialize in AI and ML.
So they're builders, but focused on ML.
Precisely.
Yeah.
Their mission is to take the experimental models that data scientists might develop and build, deploy, and maintain them as robust, scalable software in production environments.
Ah, bridging the gap from lab to real world.
Yes. They handle MLOps machine learning operations. That means data pipelines, writing production-grade code, tuning models, integrating them via APIs, monitoring them, the whole life cycle in production.
Skills for an ML engineer.
Strong CS fundamentals are paramount algorithms, data structures, software design patterns. Expert-level Python is standard, though Java or C++ might be used for really high-performance systems. Deep hands-on experience with major deep learning frameworks like TensorFlow or PyTorch, understanding MLOps tools and cloud infrastructure like AWS SageMaker or Google AI Platform, and familiarity with big data tech like Spark is often needed too.
And the job market here.
This is one of the fastest growing, most in-demand, highest paying specializations out there. It's a fantastic, natural, and really rewarding path for CS grads.
How do you prove you're ready for an ML engineer role?
Your portfolio needs to showcase both strong software engineering skills and deep ML understanding. Show end-to-end deep learning projects, maybe computer vision, NLP. Show production quality code. Show you can deploy a model as a working service. If we connect this back to the bigger picture, this fragmentation within data science, it's a clear signal. Deep specialization, combined with those solid engineering skills, is becoming absolutely critical for making a real impact.
Yeah, it's not enough to just know the theory.
You need to know how to build with it. Reliably, scalably.
Makes total sense. Okay, one last pillar to explore. The visionary's product management. This one sounds different.
It is quite different. It's a really unique, often highly influential role. It sits right at the intersection of business strategy, technology, and user experience.
So they're not coding or building infrastructure directly.
Not usually, no. They focus on the what and the why of building technology. They define the product vision, guide the execution, make sure user needs and business goals are met.
They're sometimes called the CEO of the product, right?
That's a common phrase, yeah.
Yeah.
Because they have that holistic responsibility. They do market research, user research, create product roadmaps, work constantly with cross-functional teams, engineering, design, marketing, sales, legal, everyone. And ultimately, they're accountable for the product success, metrics, growth, engagement, revenue, things like that.
What kind of skills does a product manager or PM need?
Primarily, it's soft skills. Exceptional communication, written and verbal. Leadership and influence, often without direct authority over the teams they work with. Strategic thinking, and deep empathy for the user.
What about hard skills?
They need supporting hard skills too. Business acumen, understanding markets, competition, pricing, data analysis defining KPIs, analyzing user behavior, maybe basic SQL, understanding UX principles, and crucially, technical literacy.
Ah, so the CS degree helps there.
Absolutely. It provides an excellent foundation. It means you can have credible conversations with engineers about technical feasibility, architecture trade-offs.
Yeah.
That's indispensable for a PM.
Okay, this sounds like a dream job for some CS grads, strategic, impactful, working with lots of people. But what's the reality of getting into it?
This is where it gets really tough. The junior job market for product management is exceptionally challenging and intensely competitive.
So?
Simply put, the supply of people aspiring to be PMs vastly outstrips the demand for actual junior PM talent. There are very few entry-level PM roles.
So those associate product manager or APM programs?
They exist almost exclusively at the top tech companies, think Google's APM program. But they are incredibly competitive. Acceptance rates can be like 0.5%, astonishingly low.
Wow. So applying directly is unlikely to work.
For most new grads, yes, very unlikely. The most viable and frankly the most common path is multi-step.
Which is?
You excel in a related technical role first.
Yeah.
Software engineering, UX design, data analysis, something like that. Do that for maybe 1 to 2 years at a company that's really product focused.
Build credibility internally.
Exactly. Build domain knowledge, build credibility, develop your product sense by working alongside PMs, build your internal network, and then make an internal transfer into a product management role.
That's a real eye-opener. The path isn't what you might think. It really highlights needing that strategy you mentioned earlier.
It really does. It requires patience and a plan.
Okay, you've laid out these incredible specializations, these pillars, but let's get practical again. How do you actually prove you belong in one, beyond just listing skills on a resume? Let's talk about crafting your entry.
Right. The resume is necessary, sure, but it doesn't truly prove you can do the job. The single most powerful tool you have to differentiate yourself is a well-crafted portfolio.
We keep coming back to the portfolio.
Because it's that important. And think of it not just as a website, but as a dynamic collection of work products, things that directly simulate what you'd actually deliver in the target role.
Simulate the deliverables?
Okay. And the most impactful strategy. Meticulously tailor those work products to the specific companies and roles you're applying for. Show them you understand their challenges and can deliver the kind of solutions they need.
Okay, give us some concrete examples. What would tailored projects look like for these different roles? Let's start with software engineers.
Sure. For front-end, build a really polished, responsive React web app. Maybe a task manager, a simple e-commerce site, or even clone the UI of a popular app you admire. Focus on clean code, good architecture, API integration, professional look and feel. Your own portfolio website, if done well, is also a project.
Okay, back end.
Build a robust, RESTful, or GraphQL API. For hypothetical apps, social media, hotel booking, game server, whatever, emphasize a clean API design, logical database schema, secure authentication, maybe deploy it to the cloud, show the back-end thinking.
And mobile, you mentioned publishing.
Yeah, for mobile, the gold standard is build and successfully publish a complete app to the App Store or Google Play. Utility app, a simple game, an app that uses a public API. Getting it through the review process and live is huge.
Got it. What about for the guardians, the cybersecurity folks? How do they build a portfolio?
For defensive analysts, setting up a home lab is fantastic. Virtualize machines, install a SIM like Security Onion, set up firewall rules, run some simulated attacks, detect them, analyze them, and then write a detailed report on your findings and process.
That sounds really practical.
It is. For offensive security, detailed write-ups from Capture the Flag competitions are great. Post them on a blog or GitHub. Explain your thought process, the technical steps you took to solve the challenges. Shows how you think.
Nice. And for the enablers, DevOps, SRE, cloud engineers, how do they prove their infrastructure skills?
Build an end-to-end CI/CD pipeline for one of your own software projects. Use GitHub Actions, Jenkins, whatever. Automate the build, test, and deployment to a cloud target, AWS S3, EC2, ECS, doesn't matter. Show the automation.
Okay.
Even better, maybe, is an infrastructure as code deployment using Terraform. Define and deploy a complete cloud stack VPC, subnets, security groups, load balancer, servers, database, all in code. Put that code on GitHub. That's concrete proof you can build repeatable infrastructure.
Yeah, Terraform seems key there. All right, the strategists, data analysts, scientists, ML engineers.
For data analysts, that end-to-end analysis project we talked about. Find a compelling data set. Kaggle's great for this. Do the whole thing. Acquisition, cleaning, exploratory analysis, EDA, with Python, Pandas, Matplotlib. Then build a polished, interactive dashboard with Tableau or Power BI. Tell a story with the data.
And for data scientists, ML engineers.
A predictive modeling project. Take a public dataset, define a prediction problem, regression, or classification. Document everything. Feature engineering, why you chose certain models, how you evaluated them, what the results mean. For ML engineers specifically, push it further. Show an end-to-end deep learning project, maybe computer vision or NLP. Focus on production quality code. Deploy the model as a functional API or service. Show it works.
Okay, and finally, for those aspiring product managers with that tough entry path,
Yeah.
what's their portfolio secret weapon?
The quintessential PM portfolio piece is the product teardown and redesign proposal.
Okay, break that down.
Choose a well-known product, ideally one from a company you want to work for. Do a deep dive. Analyze its strategy, its users, its business model, its strengths, its weaknesses. Then propose a new feature or a significant improvement. Create user stories for it, maybe some low-fidelity wireframes in a tool like Figma, and outline a high-level roadmap for building it. Shows you think like a PM.
That sounds really effective.
Even better, build and launch a small side project yourself. A newsletter, a no-code app, a simple mobile app. Act as the PM for it, and meticulously document your process. How you identified the problem, defined the MVP, got user feedback, measured success, shows you can actually do it.
Wow, these project ideas are gold. Beyond projects, though, what about certifications? There are so many out there. Which ones actually matter in 2025?
Yeah, it's easy to get lost in the Cert C. But a few really do carry weight. For cloud computing, the AWS Certified Solutions Architect Associate is widely seen as the gold standard for demonstrating real understanding. The AWS Certified Cloud Practitioner is a good starting point, too.
Okay, cybersecurity.
CompTIA Security Plus is the baseline for entry-level defensive roles. It's almost expected now. For offensive, the Certified Ethical Hacker, CEH, is known, but as we said, the OSCP is much more respected for practical skills.
DevOps and Kubernetes.
The Certified Kubernetes Administrator, or CKA. It's a challenging, hands-on exam, so passing it really proves you know Kubernetes well. Highly respected.
And product management? Any certs there?
Experience always trumps certs in PM. But something like the Certified Scrum Product Owner, CSPO, can be useful. It shows you understand Agile and Scrum, which is how most tech teams work. Doesn't hurt, but it won't get you the job alone. This whole section really just underscores that critical point. Demonstrable ability shown through a tailored portfolio that's often way more impactful than just a resume listing skills. It literally shows employers you've already done the work, and that's exactly what they want to see.
That's such powerful advice. Okay, so you've built your skills, you've got your portfolio. Now, where do you take them? Let's talk about navigating the job hunt itself, specifically the choice between, say, a fast-paced startup and a huge Fortune 500 giant.
Right, and this isn't just about, like, the size of the office coffee machine.
Yeah, right.
It's a fundamental trade-off: structure versus ambiguity. Each environment offers really distinct advantages, challenges, ways of learning, and even their hiring processes reflect their core values.
Okay, so let's compare them. How do roles and responsibilities differ?
In a startup, you're almost always a generalist. You wear multiple hats. You might touch front-end code one day, debug a database query the next, maybe even jump on a sales call. Roles are fluid, ownership is super high.
And in Fortune 500?
You're typically a specialist. Your role is highly defined, often focused on a specific feature or component. You become a deep expert in a narrower domain.
The pace and culture must be wildly different, too.
Oh yeah. Startups are famous for being fast, agile. Quick pivots are common. The culture is often intense, heavily influenced by the founders. Speed is usually prioritized. Fortune 500s, more structured, process-driven. Things move slower, more methodically. There's more corporate structure, sometimes more silos between teams.
What about learning and growth? Where do you learn more?
It's different kinds of learning. Startups often offer breadth over depth. The learning curve is incredibly steep. It's accelerated, hands-on, often trial by fire. You learn a lot, very quickly, across many areas.
Okay.
Large corporations typically offer depth over breadth. You get opportunities for really deep technical mastery in your specific area. There are often structured mentorship programs, clear career ladders for advancement.
And your individual impact, does it feel different?
Hugely. At a startup, your work can be immediately visible. You can have a direct, significant influence on the company's direction. You feel like a big fish in a small pond.
Right.
At a Fortune 500, you're contributing to something massive, but your individual piece is smaller. Impact is often measured more at the team level, maybe over longer timelines. You're part of a huge machine.
Let's talk money and stability. Big difference there, presumably.
Massive difference. Startups usually offer lower base salaries. The potential upside comes from high-risk equity or stock options. Could be life-changing, could be worth nothing. Job stability is inherently lower. Startups are volatile.
And the giants.
Fortune 500s generally offer top-of-market salaries, annual bonuses, often restricted stock units, RSUs, which are like cash, excellent benefits packages, and much, much higher job security typically.
And finally, how do their hiring processes compare? Do they look for different things?
They definitely reflect the cultures. Startups tend to focus more on culture fit, raw potential, adaptability. Interviews might be less structured, faster. They're testing your raw problem-solving skills, how quickly you learn, and if you're passionate about their specific mission. Fortune 500s. The focus is much more on skill fit and following the process. Interviews are highly structured, standardized, often many rounds. They rigorously test your specific technical competencies against the job description and your behavioral fit for a large organization.
This comparison is so key. You really need to ask yourself, are you a builder who thrives in a bit of chaos, likes wearing many hats? Or are you a learner who wants that structured mentorship, the chance to go really deep in one area?
Exactly.
Your answer there could totally shape your first few years in tech. It's a crucial self-assessment. Okay, last section. Let's talk about networking. It often gets overlooked, but it's so important, right?
Absolutely vital. And networking isn't just about finding your first job. It's about building your entire professional ecosystem over your career. Finding mentors, learning from peers, discovering opportunities you'd never see otherwise.
And referrals. They're huge, aren't they?
Referrals are a primary source of hires at tons of companies. Having someone inside who can vouch for you, even just get your resume looked at by a human, that can make all the difference. A strong network is key for that.
So what are some actionable strategies? You mentioned the informational interview. That sounds useful, but maybe a bit intimidating.
It can feel that way, but it's probably the most effective, underutilized tool out there. The key is the approach.
How so?
Don't treat it like a job application in disguise. Go in with genuine curiosity. Your goal isn't to ask for a job, it's to ask for advice, for insights. People generally love talking about their experiences.
So how do you set one up?
Find people on LinkedIn who are in roles or companies that interest you. Send a short, polite, concise message. Mention something specific you admire about their work or company, and ask for just 20 minutes of their time to learn from their journey. Keep it brief and respectful of their time. Most people are surprisingly willing to help.
Okay, that sounds manageable. What else?
Leverage your alumni network. That shared connection, your university, is an immediate rapport builder. Use LinkedIn's alumni tool or your university's own portals. Mentioning you both went to university name, if known, otherwise the same school in your outreach makes it much less cold.
Good tip. What about online communities?
Engage genuinely. Be an active, helpful contributor in relevant subreddits, Discord servers, maybe open source projects related to your field. Answer questions, offer help, participate thoughtfully. You build a reputation, people notice, and opportunities can pop up organically from those connections.
And good old-fashioned events. Meetups.
It's still valuable, whether they're virtual or in person. The key is preparation. Have a concise intro, ready in who you are, what you're interested in, have a few thoughtful questions prepared. The goal isn't just to collect contacts, it's to have a few meaningful conversations that you can actually follow up on later. Build real connections, not just a list of names. Remember, building this network isn't a one-time task for the job hunt. It's about building your professional ecosystem for the long haul, finding mentors, allies, people you can learn from throughout your career.
That's a great way to frame it. Okay, let's try to wrap this up. This deep dive, it really shows the tech landscape in 2025 is just packed with opportunity for CS grads.
Absolutely.
But the key to unlocking it seems to be a really strategic, self-aware approach. You need to choose a specialization, embrace AI as foundational, develop those T-shaped skills.
And build that compelling portfolio. Can't forget that.
Cannot forget the portfolio. So maybe a final thought for our listeners to chew on.
I think it's this. The industry is incredibly vast. There really is a place for every kind of talent, every kind of temperament. So as you're charting your course, you really need to ask yourself some tough questions.
Like what?
Like, what specific problem out there genuinely excites you? What do you actually want to spend your days working on? How do you personally prefer to learn and grow? Are you energized by structured learning or by figuring things out on the fly? And maybe most importantly, what's your personal tolerance for risk versus stability? For ambiguity versus clear definition? Are you that builder who thrives in chaos or the learner seeking structure?
Answering those questions for yourself, that sounds like the real starting point. Not just picking the hottest field, but finding the right fit for you.
Exactly. That self-awareness is crucial.
So combine that strong CS foundation you've built with a deliberate focus on a specialization that excites you. Commit to being a lifelong learner because this field never stops changing. And proactively build that tangible proof, that portfolio showing what you can do.
The journey really does begin now.
It certainly does. Lots to think about.